Imagine a place so dark, so cold, and so distant from the sun that it might as well be another planet. A world cloaked in blackness, where the pressure can crush as steel and sunlight has never touched the seafloor. Yet beneath the crushing silence of the deep ocean, there's a strange kind of oasis, one that doesn't rely on light to sustain life. Instead of sunlight, it thrives on something we often consider deadly methane. How do creatures survive here, in a world of poison gas and crushing pressure? What bizarre adaptations allow them to not only endure, but flourish where almost nothing else can? Today we dive into the mysteries of methane seeps and the terrifying yet beautiful life that blooms in the black. So what exactly is a methane seep? Imagine the Earth itself exhaling. Deep beneath the ocean floor, methane gas formed from the slow decay of ancient organic matter builds up pressure over thousands of years. Eventually, it seeps through cracks in the seafloor, bubbling up into the water column like a submarine volcano. But instead of molten lava, it spills invisible fumes of gas. These seeps create a strange kind of ecosystem. Instead of using sunlight for energy like forests or coral reefs, life here uses chemical reactions, a process known as chemosynthesis. This isn't just weird, it's revolutionary. It's one of the only places on Earth where life exists entirely independent of the sun. Meet the architects of this strange kingdom, methane-eating microbes. These single-celled organisms are the unsung heroes of this ecosystem. Without eyes, mouths, or limbs, they feast on methane and convert it into energy, much like plants convert sunlight. They form massive colonies, spreading like ghostly white carpets across the ocean floor. These mats become the foundation of the food web, supporting worms, clams, and even crabs. But here's where it gets truly alien. Some of these microbes form symbiotic relationships with bigger creatures, living inside them and feeding them directly. It's like having your own internal farm of bacteria growing your food. Now let's talk about the monsters, or should we say marvels of this hidden world. One of the most iconic is the lamellobrachia tube worm. It can grow over 6 feet long and live for more than 250 years. With no mouth or stomach, it survives entirely off bacteria living inside its tissues. Then there's the seep mussel, which filters not water but methane-rich fluids. And don't forget the yeti crab, covered in what looks like white fur. That fur? It's actually colonies of bacteria the crab farms by waving its claws in methane-rich waters. Every creature here is a Frankenstein of adaptation, evolved to survive in a place most animals would perish instantly. Methane might be a power source here, but it's also deadly. For most organisms, too much methane and hydrogen sulfide is like being poison. So how do these creatures survive? Many have evolved special proteins to detoxify these gases or convert them to nutrients. Others depend entirely on symbiotic microbes that neutralize toxins for them. Some worms have no digestive system at all. They simply absorb nutrients created by their bacterial partners. Even more fascinating, many of these creatures can go dormant for years if the seep stops flowing, waiting for another leak to start the cycle again. It's the ultimate gamble of survival. Let's take a step back, because this isn't just about Earth. If life can thrive in complete darkness, at crushing pressure, fueled by toxic gas, then who's to say it couldn't exist on other planets? Moons like Europa or Enceladus have oceans beneath ice sheets, and they may have methane seeps too. NASA is actively studying these ecosystems as analogs for alien life. What if methane-breathing microbes or tube worm-like creatures are hiding beneath the ice of distant moons? The deep sea may be the best training ground we have for finding life beyond Earth, and what we discover here might just change everything we know about biology. The creatures of methane seeps defy every rule we thought defined life. No light, no oxygen, no problem. They are living proof that nature always finds a way, especially in the dark. But many of these ecosystems are fragile. Deep sea mining and oil drilling threaten their very existence. We've only explored a tiny fraction of the deep sea, and we're already putting its oldest inhabitants at risk. As we end this journey, ask yourself this: if life can bloom in poison gas and eternal darkness, what other secrets is the ocean still hiding from us?